Hello, everybody. Okay, today we are going to talk about removable appliances. This is part one of a two-part lecture. Okay, the learning outcomes for this lecture is the ability to classify the type of appliances used in orthodontics, outline the materials used in construction of various orthodontic appliances, explain the uses of stainless steel in orthodontics, identify the components of a removable appliance, outline the types of clasp, labial bow springs, and their uses. Okay, what are removable appliances? Removable appliances are orthodontic devices which can be taken out by the patient for cleaning purposes and which are designed to apply forces to the teeth by means of springs or screws and other mechanical components. Now, mm, strictly speaking, a removable appliance may be an active removable appliance, it can be a mouth guard, it can be a removable retainers, or it can be a removable functional appliances. Now, in this chapter, we will concentrate only on active removable appliances. Removable retainers will be covered in a lecture concerning retention and retainers, and removable functional appliances will be covered in a lecture on myofunctional appliances. So in this lecture, we are going to look only at active removable appliances. Okay, we can classify removable appliances as active appliances or passive appliances. Now, active appliances consist of upper removable appliances, myofunctional appliances, and bite plates. And these appliances cause some form of movement of the teeth. Now, passive removable appliances is passive, meaning it does not cause any movement of the teeth. And this can either be a retainer or a space maintainer. Okay. Now, what are the advantages of a removable appliance? A removable appliance can be removed by the patient on socially sensitive occasions, and because of this, it is appealing to patients, especially adults. Now, because it can be removed, the patient can maintain a good oral hygiene, and the appliance can also be kept clean. Now, removable appliances are inexpensive and they're easy to make and adjust, and because they are fabricated in the dental laboratory, the chairside clinical time is usually less. Okay. Also, the palatal coverage in a upper removable appliances increases the anchorage available for tooth movement. There's less risk of iatrogenic damage, example root resorption. Now, the base plate in a removable appliance can be modified to form either an anterior bite plate or a posterior bite plate. Now, in a mixed dentition, the base plate can be trimmed to accommodate deciduous teeth that are exfoliating or to accommodate permanent teeth which are erupting. Now, what are the disadvantages of removable appliances? First and foremost, removable appliances depend on patient cooperation for their effectiveness, and they are only capable of simple tipping movements, and usually it is limited to movement of one tooth per quadrant. Now, lower removable appliances are not well tolerated, and rotations are difficult to treat with removable appliances. In extraction cases, it can be difficult to close residual extraction spaces. And because removable appliances are removable, there's a greater chance of the appliance being misplaced or damaged. Now, the fabrication of removable appliances also need a capable technician and good laboratory facilities, and speech may be affected temporarily due to the palatal coverage of the base plate. Now, intermaxillary traction is difficult to achieve with removable appliances, and thus removable appliances are now generally used as an adjunct to fixed appliances. Now, how does removable appliances work? Now, removable appliances induces tipping of the teeth around a point, and this point is the center of rotation, and it lies about 30% to 40% from the apex when you consider the whole length of the tooth. Now, the force required to move or tip a single rooted tooth is about 25 to 50 grams of force. Now, the optimum force depends on a number of factors. It depends whether a single or multi-rooted tooth. A single rooted tooth requires less force to tip it compared to a multi-rooted tooth. The type of movement that is envisaged, for example, tipping movements require less force than bodily movements. There is also individual biological variation between different people. Now, in this diagram, we can see there's a center of rotation and there's a center of resistance. Now, any force that is applied through the center of resistance will cause bodily movement, and any force that is applied anywhere apart from the center of resistance will cause rotation about the center of rotation. Now, appliance wear. Removable appliances must be worn full time, meaning they are only removed for cleaning and meals and contact sports. Now, the importance of adequate wear should be stressed to the patients and preferably must be reinforced with printed instructions. Now, appliance hygiene and care. Now, this can be easily achieved by gently brushing it with a toothbrush, especially on the fitting surface of the removable appliances. Now, specialized cleaning agents are not essential, and it's important that the removable appliance is kept moist when not in the mouth. Now, this is to ensure dimensional stability, as if the appliance is allowed to dry, distortion of the appliance will occur. Now, anchorage. What is anchorage? Now, anchorage is the resistance to unwanted tooth movement. As we know from Newton's third law of motion, every action has an equal and opposite reaction. Now, only one or two teeth moved, uh, moved at a time. A larger number of anchoring teeth and reaction force is shared by the anchoring teeth. Now, palate reinforces anchorage via base plate contact, and the base plate also contacts with all the teeth, which also enhances their anchorage. Now, in certain situations, reciprocal anchorage comes to play, whereby the loss of anchorage in the anchor teeth is desirable. Okay, here is a situation where the movement of two teeth is anchored by all the remaining teeth. Okay, and this diagram shows the concept of palatal anchorage. Because the base plate is in contact with the palate, the base plate helps to resist the reaction of uh, tooth teeth that is being moved. Now here we can see that the base plate is closely adapted to the palatal surfaces of the upper teeth, and this contact of the base plate with the teeth enhances the anchorage. Now this is what is meant by reciprocal anchorage, whereby the movement of one teeth causes anchorage loss in the other teeth, and which leads to a desirable result. Okay. Now designing upper removable appliance. Now this designing is usually done through a dental laboratory prescription. Now it is very important that the prescription is done by the clinician and should not be left to the dental technician. Now this is done using a laboratory cut, and the design must be in a diagrammatic form as well as a written form. Okay. The diagrammatic prescription carries the design of wire components and placement of the wire components. It also shows the placement of screws. It should show the design of the base plate and plus any modifications that is needed to the base plate, and it should show where the base plate should be split if splitting is required. And sometimes it's not just enough to show a occlusal view of the design, but we may need to show anterior and lateral views. Now, the written prescription should name the components, for example, the wire work and acrylic modification needed. It must specify the diameter of stainless steel wire for each component. It should describe the layout of the base plate modification. For example, it may state half occlusal coverage of upper right and lower, upper left, DE and 6. And any other information required should be listed on the prescription. For example, instruction to block deep undercuts. Okay, these are examples of prescription drawing. Here in the first diagram, we see a Z spring or so-called double cantilever spring. Now this is a buccal canine retractor. This is an southern clasp. Now this one is Adams clasp on the sixes, and there is a C clasp on the canines, and this is a labial bow. Okay, now accurate drawing of the required design is important. For example, if we compare these two drawings, we can see in the first drawing the whole occlusal surfaces of the posterior teeth is shaded, meaning what is required is a full occlusal coverage by the bite plane. Whereas on this second diagram, we see the shading is only done on the palatal half of the occlusal surfaces. So the required posterior bite plane here is a half occlusal coverage plane. Okay. Now this is an example of the diagrammatic and written instruction to the dental laboratory. As here we can see a clear instruction is given to the lab to construct a URA to expand the upper arch, and the position of the expansion screw is shown, and it is to move the upper left DE at 6 buccally. Now, the required Adams clasp is on the upper right 6, upper left 6, and it should be made in 0.7 millimeter hard stainless steel wire. Now, the Adam clasp on the upper right D and upper left D is made of 0.6 millimeter hard stainless steel wire, and the south hand clasp on the upper right one and upper left one is made from 0.7 millimeter hard stainless steel wire. Now there's instruction to put a half occlusal coverage posterior capping or posterior bite plane, and the split in the base plate is drawn where the split is needed. Okay, then we may also give further special instructions for certain situations. For example, in this case, a flat anterior bite plane is requested, and we have to note on the instruction that the overjet of the patient is 8 millimeters. So, and the instruction is to extend the anterior bite plane to a distance of 11 millimeters posteriorly. Okay, and the depth is two-thirds the height of the upper central incisors. Now, why this is important? Now, if this overjet is not stated in the lab instruction sheet, the technician say may only extend the anterior bite plane 6 millimeters posteriorly, and in which case, when it is worn in the mouth, the lower incisors will not occlude on the anterior bite plane, and meaning the anterior bite plane will not be effective. Okay, the URA design can be remembered by using an acronym, ARAP. Now, this stands for active components are retention, A, anchorage, and B, base plate or connector. Now, let's look at the active components. Now, before we decide on the active components, we have to decide which tooth or teeth to move, what active component to use to achieve the movement. Now, the choice of active components are three basically: springs or labial bows, screws, and elastics. Now, let's compare springs and screws. Now, the springs are usually preferred because it is activated by the operator or clinician, whereas screws are turned on a daily or weekly basis at home, and thus it depends on patient cooperation. Now, springs are less bulky, whereas screws are more bulky, and springs are cheaper in cost, whereas screws are more expensive. Now, springs are preferable for moving one or two teeth, but if we are moving multiple teeth, then screws are preferable. And also, the another advantage in screw is it can provide additional retention using the teeth to be moved. Okay, this is what I mean. If you look at this diagram, now this appliance has a screw here which aims to move this uh, upper left molar distally, and by putting a clasp on the upper left molar, additional retention is obtained from the tooth which is also being moved. Now, labial bows are used to reduce overjet and close spaces distal to canines. Now, labial bows are only suitable for mild overjets since no bodily control is available in a removable appliance. Now, if it is used for severe overjets, this will cause over retroclination of the anterior teeth. Now, what are the recommendations for active components? Now, if the intention is to tip the anterior teeth over the bite, the preferable component is a Z or double cantilever spring. Now, if the same is being done to a buccal teeth, then the preferable component is a T spring. Now, movement of teeth mesially or distally along the line of the arch is best achieved with a finger or palatal spring, and this should be boxed and guarded. Now, buccally displaced and mesially angulated canines are best moved using a buccal canine retractor. Please remember that distally angulated canines cannot be treated efficiently with removable appliances. Okay, these are diagram showing the uh, what is a Z spring. Now this is a T spring. This is a fingers or palatal spring, and this is a buccal canine retractor. Now, the stability of the finger spring. The spring must contact the teeth tooth in such a way that the tooth moves in the planned direction, and the spring must lie in a V-shaped channel or box cut out of the base plate, and it should have a guard wire over the free length of the spring just before the spring emerges from the acrylic. Now, the box and the guard wire prevents the distortion of the spring and allows free, unobstructed free of spring movement. Okay, here in this direction, this diagram, you can see the box that been cut in the acrylic, which allows freedom for movement of the spring, and you can see this guard wire which guards the spring and prevents the spring getting distorted. Now, the third active component is elastics. Now, elastics are limited use in removable appliances. They are widely used in fixed appliances, but with removable appliances, they can be used to extrude surgically exposed tooth or to extrude partially erupted tooth. Let's have a look at retentive components. Now, retentive components appliance must have both anterior and posterior retentive components. But anterior does not necessarily mean the retention must be on the central incisors. It just means that it should be as far forward or anteriorly as possible. Now, some retentive components commonly used are Adams clasp, which is very popular, a southern clasp, which commonly used on two anterior teeth but can also be used on a single tooth. A labial bow can also be retentive as well as a active component, a C clasp. Now, placement of the clasp depends on the space available to move the teeth. For example, now if we want to move a upper lateral incisor into the space between upper central and upper canine, then we cannot place a clasp on the upper canine or upper central incisors, as this will interfere with the movement of the upper lateral incisor. Now, the layout of distribution of retentive components usually either in a rectangular or square uh, format, or it may be in a triangular format. Okay, here we see what is meant by a rectangular square format of retention. In this diagram, you see you have clasp on the first premolars and the first molars. So the retentive distribution is in a square rectangle, and in this direction we have two Adams clasp on the first molars, and you have a southern clasp on the upper central incisors. So here the retentive components are in a triangular fashion layout. Now, base plate or connector. Now, base plate or connector can be either be a plain base plate, meaning it is unmodified and acts purely as a connector, or it can be modified into either an anterior biplane or a posterior biplane. Now, anterior biplane can either be a flat biplane or an inclined biplane. The posterior biplane can either be a partial occlusal coverage or a full occlusal coverage posterior biplane. Now, what does the anterior biplane does? The anterior bite plane basically is a flat layer of acrylic built up behind the upper incisors. Now, depth of anterior bite plane must be more than the overjet. Otherwise, the lower incisors will not occlude on the bite plane. Now, the anterior bite plane discludes or separates the buccal teeth. Now, this separation causes eruption of the buccal teeth, which helps to reduce the deep anterior overbite. Okay, now posterior bite plane. A posterior bite plane is commonly used to correct the anterior crossbite. The separation of the anterior teeth caused by the posterior bite plane helps to move the teeth or tooth or teeth over the bite. Now let's have a look at the wire prescription used in removable appliances. The wire used is always stainless steel. Now the dimensions that we see in a lab design sheet refers to the wire diameter. Now the relationship between the force applied and the diameter of the wire is given by the equation. Force is proportional to uh, diameter times radius to the power of 4 divided by the length to the power of 3. Now, a retentive component for the permanent teeth is made from 0.7 millimeter stainless wire. For deciduous teeth, it is 0.6 millimeter stainless steel wire. Now, the active component for springs that are used to move one tooth, it is 0.5 millimeter stainless steel. Now, for springs used for moving two teeth or to move a single large tool, it may be zero point 0.6 or zero point 0.7 millimeter stainless steel. Okay, so the references for this lecture is these are the two references, and thank you for listening.